Okay guys, so let's start with lab 2. In this lab, the task is to have the mutual redistribution of route between Eigrp and RIP, right? So we haven't done the RIP labs, I haven't done that for the video purposes, but I hope that you guys know something about it. So RIP actually works on hop count. So the metric of the RIP is a hop count, and the metric of the Eigrp is the complex metric, composite metric, right? So the idea what we are trying to do here in this lab is that we will take router 1, right? We can, I should have, but we don't have that. Okay, so we have router 1, and inside the router 1, let me see if I have my pen. If I can write something here. So let's put this guy here. Let's take this one. So the idea is that this guy will be using this guy. So this guy, and this is very small. Okay, let's pick this. Let's pick a different color. Let's delete whatever we have on the screen. Now, so this guy is going to speak both RIP and Eigrp, right? So he's going to speak RIP on the upper side and Eigrp on the lower side. So we're already running Eigrp on this end, right? So what we are going to do, we will remove this interface from Eigrp, right? And we will remove Eigrp from here, right? So this will be removed, and we will add RIP here, just for the sake of this lab, right? So let's see what can be done. So let's go back. This is our lab, so let's press enter. So what I'm going to do here is that I'm going to remove router Eigrp 100, and I'm going to say router RIP version 2, no auto summary, right? This is the basic things we're gonna do, and then I'm gonna advertise both the networks, which is my interface and my loopback, right? So that is it from router 1 perspective. Now on router 2, what we are going to do is that we are going to say router RIP version 2, no auto summary, and then we will advertise the two networks there, right? So let's do that. Two networks are networks 12.0, and we will be doing network 2.0, right? Network 2.0. Right. And what to make it more interesting, what I will do is I will create a loopback, another loopback on router 2, and I will say IP address 22.2.2.2, and that will be also /u. So that's the loopback, normal loopback like we did on the other hand. And what I will do is that on Eigrp 100, if you look at the current config, we have these two networks here, right? So I'm going to remove these two networks, so I'm going to say no to these two networks, and I will add the 22 network here, right? So this is what we have done. So now if we look at the RIP route, so should IP route RIP, we see that we have one network, right? We are receiving one network from router 1, which is the administrative distance of 120, which is RIP, and the hop count is 1. So if you look at the picture, right, so you can see that for router 2 to read the loopback of router 1, it has to go to router 1, which is 1 hop, and then it will go to that network, right? So this is the correct representation. Now if we look at the Eigrp routes here, you see that we are receiving 3, 4, and 34, right? 23 is recognized, so 3 is loopback. I haven't seen that guy. That's strange. Why? Let's see that. This is 3. So 3, and we are receiving 4, and then we are receiving 34, the network between them, right? The if you go to other sites, you will see 22 there as well. So like if I go on router 4 and I do show IP route EIGRP, I should see 22 here as well, right? Which I recently advertised. So no matter where you go, you will see those stuff. So now our task is to redistribute EIGRP into RIP and RIP into EIGRP. Now the problem here is that we can do this only on router 2, because router 2 is the only router which is picking both protocols or the language, right? The RIP for router 1 and EIGRP for the rest of the network. So if you go on router 2 and if you go on to router RIP and then we redistribute EIGRP 100, we have to, if we don't define a metric, let's say I just do this, right? And if I go on router 1 and if I look at the route, I only see one RIP route, which is actually defined in RIP here, right? Which is there with the network 1. So that's the only route router 1 is receiving, even though I have redistributed it. The reason why this redistribution command is not working, because the metric of EIGRP is not equivalent to the metric of RIP. So when I'm trying to redistribute these routes, router is saying, okay, I'm going to redistribute them, but this is the metric, and this metric is not going to work. So we have to change the metric. So how are we going to change that? We can say redistribute EIGRP 100 and then the metric, and then we define a metric. So that so metric can be what? From 0 to 16. So let's say we define 2, right? We define 2. Now what will happen that on router 1 we are going to see other networks, but see what's happening. What's happening is that whatever we are receiving with the metric of 2, which is not the correct representation which we discussed from router 2 perspective. Now if you look at this 3 network, this is 1, 2, so this is 2 hops away, right? 2 hops away, but here it's showing 2, so that is fine. So what about 4? So 1, 2, 3, so this is 3 hops away, but it's still showing me 2 hops, right? So this is not the correct representation. If you want to, and this is a bit advanced, guys, so if you want to do this, we can do something on router 2 side. Okay, so what we can do first, we will remove that, no redistribute EIGRP 100, and verify that this has been removed. So it has been removed completely. And what we are going to do, we are going to create, we have to identify that which network is at what hop. This is again not a production thing. This is I'm doing it in the lab just to show you guys how these things work together. So first of all, we have to define an access list to identify all the networks. So let's identify the addresses. So access list 3, this is a standard access list where we are going to identify the loopback of router 3, which is 3.0.0.0, 0.255.255.255. So this is we are just saying that, okay, we have access list and this is the traffic we want to identify. Then we need to have 4, and then we just identify 4. So this is, we are just identifying the traffic. We're just saying that, okay, identify this traffic. What is going to happen with this traffic will tell the router what to do with this. But right now we are just saying that identify this network, identify this network. So for 34, no, 34 is different, right? So 34 is 1.1 and is 0.0, something like that, right? This is 34. This is our 34 network, so we can say 3, 4, 34. So this is 34 network. We are saying that if the network has 34.11, then mark it. So we are just making sure that we have 34. Then we have 23 as well, right? So let's do 23, and they will remain the same, but the first octet will change, right? So first 3 have to match. And remember, we created 22, so we will do 22 like this one, right? Because 22 is /8, so we'll do 22 like this one, right? Now once we have this, so if you look at do show run include access, we have these access lists, right? And this access list is doing nothing right now until unless we use it somewhere. Now if you have looked into the RIP route. So let's go to router RIP, and if we do redistribute Eigrp 100, you see that we have two options. We can either define a metric, which we did, right? Which we did previously. We defined the metric of 2, or we can define a route map, right? So that's our next objective. Our next objective is to put a route map in which we can define each network separately. So let's I'm not going to do anything here. So let's create a route map. So let's say route map test, right? Route map test, and we say permit, just like an access list, but it's an if and then statement, right? So we say this is what we want in 10. We say we want to match. Now what we want to match? We want to match an IP address which is in the access list. Okay, so access list 3. So we want to match an IP address. Whatever IP address we have in 3, match it. If it matched, then we want to set the metric to 2. This is how for the router 1, 2, and this is the 2. So we will set the metric 2. Then we have other statement like 20, and then in this one we match 4, and we say this one is 3. Set the metric of 3, and then we say 30. This one we say IP address match 23, right? 23 is how many hops? 1 hop, right? And then we set the metric to 1. Then we say 40. You can have in any order, doesn't matter, right? So 40, and then we say match 34, and then 34 is 2 hops away again. So let's metric 2, and then we have 50, which is 22, right? And in this is also with the metric of 1, and then we have the last one. Last one is necessary that if we doesn't have anything, then set the metric to 1. That's it. This is the default. So if you look at show run route section route map, if you do this, you will see that we have all these statements here. So we created a permit 10. We are matching the set. So now this whole thing. So if you look at show run include access, and you run route map, now these two together are combining. So we are saying that whatever matching the 3, put their metric to 2. So now we have, remember, we have only one option of metric here, right? Here we have only one metric. We can put one metric for everything. Now we can put individual metric for individual networks, right? And that is it. So we just go into the router RIP, and we redistribute Eigrp 100, but this time we use route map, and the route map is test. And after that you can put the metric of the redistribution, but we don't, because that's what we are doing, right? So and then we can also set the Eigrp, and we can redistribute RIP into Eigrp. So we can go into Eigrp 100, and we can redistribute again, same thing, redistribute RIP, and then we define metric. So here you do the you can do here as well, but here if you're defining a metric here, you have to define the bandwidth and all those stuff. So if I look at 1/2, I can take these values and put it there, right? So this is the easiest way to do that, right? So I can say my bandwidth is 1544, so this is my bandwidth. Then it's asking me what is the delay in microseconds. So my delay, total delay, it's asking for total delay, but I'm going to give whatever is on my interface. So that is my delay. And then it's asking me for the reliability, 100% reliable. Load, I'll show you. The load is 255 is 100% loaded. So right now this is the lab, it's not loaded. And then the last value of MTU, and MTU is 1500, the default. So I did that. So now if I go on router 1 and do show IP route, you can see that now I have the different metrics for different networks, right? So this is the defined way of doing things, right? And now if I go to router 4, I would see an external routes. So I'm receiving 1, I'm receiving 2, I'm receiving 12. So these are the external routes, and with the metric And you can see that the 3 metric and this metric because we matched everything on the interface. If you do not match it, then we can easily put 1 1 1, but then the metric will be too large. So it's always good to have a proper metric on the site. So when I say proper metric, means these values which we just put in here. Always put nearest to what we have so that the calculation is correct. Okay, that's it for this lab, guys, and then we will move on to another lab. Thank you.